My name's Ben Davis. I'm a teacher at Sahuaro High School. I've been teaching for 15 years in this state. Currently I teach physics, AP physics, and then a dual credit U of A engineering class. The thing about project-based learning that I think is really beneficial is that instead of like being in a class where you just learn a skill, like one standard one day and then you just take a test on that, we introduce the project first, and then throughout the project, they start seeing there's some skills they need to be able to be successful in the project.
The whole purpose behind the solar oven project was to cook a biscuit, because in some countries this is a good resource.
So we were given a certain amount of materials and a certain type of materials, so we had to maximize the effect of those to take the solar energy and turn it into thermal energy in order to cook the biscuits. We ended up actually creating a mathematical model on the computers beforehand to predict what our outcome temperature was going to be inside the oven. And we also did a lot of learning and how to use the Excel file and how to basically come up with our prediction equation.
This is a U of A curriculum. It's the 102 class that's taught there for all freshmen. It's the freshman design class. I use their same curriculum. But within that class, I get a lot of extra time, because if you took it there, it's a 3 credit hour class. You mean 3 hours a week, 1 semester, done. I got the extra time. I got 5 hours a week and I got them all year. So instead of having to meet outside of class time, they can do all that group meeting inside of class time, which is great because I have all the tools they need to do the work anyway. There's a process for doing engineering design. It's called design of engineering experiments. And it's a really lengthy process. And so I kind of teach them all the math behind it, but they don't get the process until they go and do it.
We were doing this for a DOE instruction, understanding what a DOE is and how it can be applied to the real world. It's definitely fun to get hands-on. I think every student loves getting hands-on. You can read things in a textbook and that you can't learn anything from that. Yeah, okay, so you're just transferring from one thing to another, but if you do hands-on, that's where the real learning is.
It's hands-on. That's the biggest thing. Yeah, it's definitely, we get to go to class and do something physically, and we're also learning at the same time.
We actually made something out of what we learned.
Yeah.
Rather than just learning it and testing.
Yeah.
Just normal tests. We actually were able to use that and come up with something that can actually end up helping the world.
They will have a short report they write with it too, so they get some practice writing technical reports. They're doing a group presentation too. So I'm giving them multiple ways to engage in the content and engage with other people and check their understanding of what we've been learning, and then try to explain it. Because I think we all know if you're the one teaching it, you come away with a way better understanding of it than if you're just the listener.
I like the fact that engineering is the basis of everything, and with this goes beyond just building a cardboard box, in places this is what people need, this is what they're looking for, and I think that element is really cool. So I appreciate everything.